welcome back to my channel. I've come up with another video. In this video, we'll be learning about Kruskal's algorithm. What is Kruskal's algorithm? It is an algorithm which helps us to find the minimum cost spanning tree of a given connected undirected graph using this algorithm. So let's find the minimum cost spanning tree. First, let us see the important points to be remembered while finding this minimum cost of a spanning tree. Here are the important points to remember. The first one, the graph should be an undirected graph. The second, we have to reach all the vertices with minimum weights. The third one, there should be no cycles formed in the minimum cost spanning tree. Fourth one, only minimum weights should be considered. It is very important to consider only minimum weights because we are finding the minimum cost spanning tree. So let us begin. Let us consider a graph with 7 nodes. A, B, C, D, E, F, and G. 7 nodes. So here are the 7 nodes and the weight between each node is as follows. I will represent the edge with red color and the weight with blue color. So the edge between A and D, has a weight of 4. The edge between D and E has the weight of 2. The edge between E and C has the weight of 10. The edge between A and B has a weight 2. The edge between D and B has 1. B and E has 3. B and C has 7. G and C has 6. B and G has 4. F and G has 1. F and B has 8. And the last edge, A and F, has 5. So this is the undirected graph with all the weights present. So let us consider a table. So this table has 3 columns. The weight column, the source column, and the destination column. So what we are doing here is we have to find the minimum weight. So let's consider the minimum weight first. The minimum weight we have 1, which is from D to B and F to G. So let us consider the weight 1 from D to B, D to B, and another weight 1 from F to G, F to G. So let us first draw all the nodes present. A, B, C, D, E, F, and G. So we found two edges with minimum weight from D to B and F to G. So let us draw them from D to B and F to G, and their weights are 1 and 1 respectively. Next, let us consider the next minimum weight in the graph 2. 2, and the edges are from A to B. So we can draw here from A to B. The edge is 2, and the next edge is from D to E. From D to E. From D to E is the next minimum edge. Next minimum weight is 3. But when we try to consider the minimum weight 3, it forms a cycle. And it is an important point to find the minimum cost spanning tree that it should not form a cycle. So we can't consider the weight 3. The next weight is 4. When we consider the edge A to D with weight 4, we can't take that because that also forms a cycle ABD. So that is also not taken into consideration. We take another edge of weight 4, which is from B to G. B to G. So from B to G, we can take 4. The next minimum edge is 5. But when we consider 5, it forms a cycle, so we can't take 5. The next minimum edge is 6. So we can take that from G to C with weight 6. By this, all the vertices have been reached through minimum edges. So the total minimum cost would be 2 plus 1 3 plus 2 5 plus 1 6, 6 plus 6 12, 12 plus 4 16. So the minimum cost would be minimum cost would be 16. So this is how you solve using Kruskal's algorithm. Thank you everyone. See you all again in another video. Bye bye.